Okay, this is the video for 9.4. We're going to start talking about linear inequalities in two variables. In 9.1, we talked about linear inequalities in one variable. So the solution set for a linear inequality in two variables is an entire region of the rectangular coordinate plane. And to graph these, here's what we do. We start by replacing the inequality symbol with an equal sign and graph the line that gives us. That's what we call the boundary line. So we draw a solid line if the original inequality was less than or equal to or greater than or equal to, so if it includes equality. And we draw a dashed line if the original inequality was strictly less than or strictly greater than. Then our next step is to choose a point that's not on the boundary line. So in one of the two parts of the coordinate plane that the boundary line divides the whole coordinate plane into. And we test that point. If the resulting statement is true, we shade the region that includes the test point. If the resulting statement is false, we shade the region that does not include the test point. So how does this work? Well, step one, we need to graph the line y equals 1/2 x. So we know, based on the section on lines, that our slope is 1/2, which means we'll go up 1 and right 2. And our y-intercept here is 0 because there's no added term in our equation. So we start with a y-intercept of 0, and from there we go up 1 and over 2. Now, we're going to draw a dashed line because our original inequality symbol was a less than. So there's our dashed line. Now, let's pick a test point. So I'm going to pick a point above the line. I'm going to pick the point 6, 7. So we're going to test the point 6, 7. So I go back to my original inequality and I plug the numbers in. So y is 7, and I need to know if that's less than 1/2 times 6. Well, 7, 1/2 of 6 is 3. This is a false statement. So since 7 is not less than 3, my test point is in the wrong area, and I shade the other part of the graph. Okay, there are a couple more examples on the next page. You should pause the video and try those on your own if you want, or you can just keep it. All right, so on number 6, we have y is greater than or equal to 2. So first of all, we need to graph y equals 2, and hopefully everybody remembers that that is a horizontal line with y-intercept of 2. So we go up to 2, and it's a horizontal line. Now this one's a solid line because we have greater than or equal to. And so now let's pick a test point. Let's pick, I don't know, let's pick 4, 4. So we'll test the point 4, 4. So we plug 4 in for y. There is no x in the equation, so it doesn't even matter what our x value is. But is 4 greater than or equal to 2? The answer is yes. So we shade the same region our test point is in. Okay, on number 7, I'm going to change this equation, x minus 3y equals 15, into slope-intercept form by solving for y to make it easier to graph. So subtract x from both sides. We get negative 3y equals negative x plus 15. Then divide everything by negative 3. So y equals 1/3 x minus 5. And this is going to be a dashed line because our original inequality was less than. So we start with a point at negative 5, up 1 and over 3 according to our slope. And now we draw a dashed line. Okay, now we need to choose a test point. So I'm going to choose the point, I don't know, 3, 0 looks like a good one. So test 3, 0. So I'm going to go back and plug into my very original inequality. So x is 3 minus 3 times 0. And we want to know if that's less than 15. So 3 minus 0. We end up with 3 is less than 15. That's true. So we shade the same part of the graph that our test point is in. Okay, that's the end of this part of 9.4. In the next video, we'll talk about solving systems of linear inequalities.